Good morning. Today is another sleepy day. I'm going to be talking about the daily warm-up number 9 from yesterday. It was to find the GCF of 45, 75, and 120. So GCF just stands for greatest common factor. Greatest common factor is the number that divides 45, 75, and 120, and the biggest one that divides all three. So first, I'm going to list out the factors. That's one of my methods. Honestly, this is one of my least favorite methods because oftentimes you're writing out a huge list and then you can't just start from the middle. You have to start from the beginning. Otherwise, your list is going to be out of order. You might miss some stuff. It's just not really one of my favorites. I do know that all numbers have a factor of 1. And the factor that goes with 1 is itself. So 45, 75, 120. Okay. Now let's check. Are any of these divisible by 2? Yes. But I mean, obviously, our common factor isn't going to be 2 or a multiple of 2 because none of these are even. So, trick to see if something is divisible by 3. You take the numbers, you take the digits of the number. So let's say 45, right? We've got a 4 and we've got a 5. So 4 plus 5, that's 9. Is 9 divisible by 3? 9 divided by 3 is 3. So yeah, checks out, divisible by 3. 15 would be the pair for that. And let's see, 75 divisible by 3, 75, 7, 5. So 7 plus 5, that's 12. Is 12 divisible by 3? Yep, checks out. Okay, so what's 75 divided by 3? I know 3/4 makes 75. Okay. 120, is it divisible by 3? I kind of already wrote it there, so you know it is. But 1, 2, 0. Let's add them all together. 1 plus 2 plus 0. That's 3. Is 3 divisible by 3? Yep. Okay, so that's 40. Okay, this is a trick that works for 3s. Don't use this trick for 4s. Don't use it for 5s. Don't use it for 6. This trick works for 3s. It also kind of works for 9s too. So let's see. 4 plus 5, that's 9. Is 9 divisible by 9? Now we're checking to see if the digits, when they add up, if they're divisible by 9. 4 plus 5, that's 9. Is 9 divisible by 9? Heck yes. Okay, so 9. All right, so I kind of went out of order. 45 divided by 9, that's going to be 5. Okay. 75, is that divisible by 9? 7 plus 5, that's 12. Is 12 divisible by 9? No. Is 3 divisible by 9? No. So 75, 120, not divisible by 9. Okay, this is a trick that is only meant for 3 and 9. You cannot do this trick for any other number. You can try it out if you want. Let me know if you do find a number that it works out for, other than 3 and 9. Okay. So then let's see. 120, I know it's divisible by 10. 10, that gets me, the pair is 12. Okay. And so if you keep going down this route, you'll end up with a complete list, hopefully. Sometimes you miss a few here and there. That's kind of what I don't like about this method. Okay, so if you get to this part, you've listed out all the factors. You see, hey, here's a 15, here's a 15, here's a 15. Any other bigger number they have in common? Nah. So the GCF is 15. Okay. So to talk about the other method, the next method that I like much better than this one. So the second method I'm going to talk about is prime factorization. Okay, prime factorization. I'm going to find the factor tree for all of these. The reason why prime factorization is so powerful is that once you find the prime factors of a number, you can find any other factor because all those other factors are just made up of the same prime factors. Let's see what I'm talking about. Okay, 45 can break that up into 5 times 9. 5 is a prime, so I'm circling it. 9 can break that up into 3 times 3. So now you've circled everything and you can't move on. That's what I like about making factor trees because there's a start and there's an end. There's no, am I missing something? So 45, that's gonna get me 3 squared times 5. Or you could write it out as just 3 times 3 times 5. Okay, so can we build the other factors from these prime factors? Well, yes, you can see 45 is also 9 times 5, but it's also 3 times 15. If I just take the 3 here, move it down here, and the 3 times 5, move it down there. Those are the other combinations that you could get. So let's move on to 75. I know 3/4 goes into 75. And then I just break up 25, that's 5, 5. Okay, easy peasy. 3 times 5 times 5. 120. That's 12 times 10. And so with prime factorization, you could start anywhere. Doing the factor tree, you could start anywhere. I don't have to start with 2. I could start with 10. Break 10 up, that's 2 times 5. 12, that's 3 and 4. 4, that's 2 times 2. Okay, so 120 is 2 times 2 times 2 times 3 times 5. Okay, then we see each of those has at least one 3 and at least one 5. So our greatest common factor, because as I said before, you could combine these prime factors to find the other factors that make up 45, that make up 75, that make up 120. You find that 75 is 15 times 5. 120 is 8 times 15. Where did I get the 8? 2 times 2 times 2. 15? 3 times 5. So you see, greatest common factor is 15. Okay. So moving on to the mental math. How do you check? Okay, so I know a lot of people. They went, hey, I know 45 ends in 5, 75 ends in 5. So these are divisible by 5. This ends in a 0, divisible by 5. So I know they're all divisible by 5. Well, clearly from the other two methods, we saw that the greatest common factor is not 5. But we know that it is a multiple of 5, okay? The greatest common factor is always going to be a multiple of its common factors. So 15 is a multiple of 5, right? Okay. So we know that this is a common factor, but it's not the greatest common factor. Okay. I'm just going to draw out what plays out in my head when I think about these three numbers, 45, 75, and 120. Okay. When I look at these numbers, I immediately think 75, that's 3/4, 120, that's divisible by 10, 45, I know that's 5 times 9. Those things, not quite useful. But then I think, I know how I can relate all of these. These are time. So 45 minutes, 75 minutes, and then 120 minutes. Okay, so if we pretend this circle is a clock, okay, I know that 0 starts there. Here's 15 minutes. Here's 30 minutes. And then there's 45. So 45 minutes is 3/4 of an hour. Oh wait, 75. I know 0 starts here. If a whole clock, if the minute hand goes around the whole clock, I know that's an hour. So this whole thing, that's an hour. But 75 minutes is more than an hour because an hour is 60 minutes. So this is going to be an hour and 15. Okay. 120, well, that's more than 60. So like color in that whole thing, that's going to be an hour. And 120, that's 2 times 60, that's 2 hours. Okay. So I can break these up into chunks of 15. 45 is 3 chunks of 15, 3 chunks of 15. 75 is what? 1. I know an hour has 4 plus 1 more, that's 5 chunks. This one is 8 chunks. Okay. Is there any way that I could build these chunks of 15? Because remember, greatest common factor is going to be a multiple of your common factor. So we know that a common factor is 15. We know that common factor is 15. Is it the biggest one? Well, can I break these evenly into chunks of 30? Nah, no. This one I can, 120, but not 75, not 45. Can I break it into chunks of 45? Well, no, then I would need 6 chunks here, but I only have 5. And I would not need 9 chunks here, but I only have 8. And I don't think I can have anything bigger than 45 because this is 45. So 15 is indeed our greatest common factor. Okay. And of course, you could think about this in another way. This is just one option out of many options. Each one of us thinks a little differently. So I hope you enjoyed this video. Um, and I will see you another time. Thank you for watching.